Hey guys, today we're doing Chapter 1, Section 4, which is on quartiles, percentiles, and box plots. So the pth percentile of a set of numbers is a value in the set such that p% of the numbers are less than or equal to that value. Some ways that you might have seen percentiles before are definitely on your Iowa assessments. They always tell you that you're in, the 95th percentile or the 90th percentile. Okay, that would be an example of a percentile because if you're in the 99th percentile, that means that you are better than 99% of students. So in other words, that means that you are in the top percentile. If you're in the 90th percentile, that means that you were better than 90% of students. Okay, and that's in the nation, of course, for the Iowa assessments, but for any percentile problem, you're just thinking about the certain population that you're testing. Okay, quartiles are values which divide the entire data set into 4 subsets of approximately equal size. The symbols we will use for the quartiles are Q sub 1, Q sub 2, and Q sub 3. So Q sub 1, that's our lower quartile, Q sub 2 is our median, and Q sub 3 is our upper quartile. Essentially with quartiles, we're splitting some sort of data set into 4 semi-equal parts, okay? And the way that we're doing that is just using medians. And we're going to talk about that a little bit more later. Thankfully, we already know about one of the quartiles, Q sub 2, that is called our median. And remember that to find a median, what you do is you order the data from least to greatest, and then you just find whatever's directly in the middle. Okay, Q sub 1 is going to be the median of the set of data below Q sub 2. So in other words, once you find that median, if you take out the median and then just look at everything under that median, and then you find the median of that data set, that is your Q sub 1. So that's called your lower quartile. Basically, you're just finding the median of the lower portion of your data. So then, of course, the median of the data above Q2 would be called Q3, which is your upper quartile. So again, after you find that median in your data set, which is Q sub 2, once you take that out and you've got everything ahead of that or above that, then you look at the median of that portion of the data. So it's just going to be the median of the upper portion of your data. So name the approximate percentile of the following. If I'm looking at Q sub 1, that's the median of my lower portion of my data. So that would be about at the 25th percentile, okay, because I'm saying that I'm above 25% of my data, which makes sense because it's a quartile, right? So it's splitting it into 4 equal parts, and this is the first of those 4 equal parts. Okay, Q sub 3 would then, of course, be the 75th percentile because it's above 75% of the data. Altogether, the minimum, Q sub 1, median or Q sub 2, Q sub 3, and the maximum make up what's called a 5-number summary. A 5-number summary is what you're going to use to make box plots, okay, or another way of saying it is box and whisker plots. So if we want to find a 5-number summary for the data listed on page 29, okay, page 29, we have a whole bunch of states, and we have the basic yearly student charges for room, board, and tuition in public colleges by state. Okay, so we've got the charges, and then we've got the states going from our smallest charge to our largest charge. So I have 50 states, and I need to think about how can I find that Q sub 2. So Q sub 2, minimum and maximum, those are always the easiest to find. My minimum is, of course, Oklahoma, which is 4,205. My maximum is Vermont, which is 10,401. My Q sub 2, that's going to be the median of my entire data set. So I've got 50 states here, which means that my median is going to be between 25 and 26. So because I have an even number of data points here, and I know that my mean is going to be between 25 and 26, what I have to do is I have to take 25 and 26, which are Alaska and Minnesota, and I need to find the average of those. So what I'm going to do is take 6,156 plus 6,182, and then I'm going to divide that by 2, and I get 6,169. Okay. Then what I can do is I can split this data set into the upper and lower portions. So for my lower portion, I'm going to go from 1 to 25, so Oklahoma to Alaska. And for my upper portion, I'm going to go from 26 to 50, or Minnesota to Vermont. So looking at my lower portion, if I want to find the median of this lower portion of my data set, I've got from 1 to 25. So halfway between that would be number 13, which is Kentucky. So that number is 5,324, and that's going to be my lower quartile. Okay, my upper quartile, I'm going to do the same thing. So I'm going from Minnesota to Vermont, and I'm looking for whatever's directly in the center, which is number 38, California, 7,922. Okay, so now I have my 5-number summary for my data set here. Now I've just got a couple questions here about percentiles. So what state is at the 46th percentile? Well, if I'm at the 46th percentile, that means that I'm above 46% of the data. So I have 50 states here in my data set. So what I can do is I can think about taking 46 out of 100, because that's the percent. I can set that equal to something out of 50 to figure out what state is at that 46th percentile. Okay, so then when I solve that, you should figure out that it's going to be the 23rd state, which is West Virginia. Okay, for the 10th percentile, you can do the same thing. So I've got 10 over 100 equals x over 50. Okay, when I solve that out, I get x equals 5. And that is going to be Tennessee. Now we can figure out the percentile rankings of numbers. So in this case, I've got $8,297. When I go through and I try to find where that is, I find that that's Maryland, which is the 44th state. So I can say 44 out of 50 is equal to something out of 100, and that's going to give me my percentile, which is going to be the 88th percentile. Okay, I can do the same thing for 6,326. So I look through my table, and I find that it's the 28th state, which is Missouri. So I can say 28 out of 50 equals x out of 100. And then I get that is going to be the 56th percentile. Okay, we also have something called an interquartile range. Another way we write it is just IQR. And the range of your data set is always the maximum minus the minimum. So the interquartile range is going to be your upper quartile minus your lower quartile. We can also find outliers using this interquartile range by using the IQR criterion. So we can say outliers are any number in a set of ordered values where we have something greater than our upper quartile plus 1.5 times our interquartile range, or we have something less than our lower quartile minus 1.5 times our interquartile range. So this is called my 1.5 IQR criterion for outliers. And basically, if I find this 1.5 times IQR and I add it and subtract it from my upper and lower quartile, it'll give me a range of my data that is reasonable, and anything outside of that range would be considered an outlier then. So check the chart on page 29 for outliers. Well, what we need to do first of all is find our IQR. So that's going to be my upper quartile minus my lower quartile. And my upper quartile was 7,920. My lower quartile was 5,324. So when I subtract those, I get 2,598. Now what I can do is take 1.5 times that So that's going to be 1.5 times 2,598. When I do that, I get 3,897. Okay, so now what I'm going to do is I'm going to add that to my upper quartile and subtract that from my lower quartile to figure out my new range. So when I add that to my upper quartile, I get 11,819. Now looking at my data set, I don't see anything that's greater than 11,819, so that means that I don't have any upper outliers. So now I'm going to go to my lower quartile, 5,324, and I'm going to subtract my 3,897. And when I do that, I get 1,427. So do I have any data that's lower than that? The answer is no. Therefore, I don't have any outliers at all. So according to my 1.5 IQR criteria, I have no outliers. Okay, and that is everything for section 4.